Lesson 15 video, Introduction to Exponents. In this video, we will start by looking back at powers of 10. Then we will explore powers of numbers other than 10. Expressions that include numbers with exponents are called exponential expressions. Remember using base 10 blocks in math class? Each little square represents 1 unit. You can stack 10 units to make a rod and place 10 rods together to make a flat. Each flat has 100 individual units because 10 rows of 10 can be multiplied 10 by 10 to give us 100. The cube contained 1,000 individual units, and we knew this because it was made by stacking 10 flats, and 100 units multiplied by 10 gives us 1,000. We can use a power of 10 to represent the cube. Since the cube contains 10 rows of 10 units stacked 10 units high, we need to multiply the number 10 by itself 3 times to find the total number of units. We can represent this repeated multiplication using the exponent 10 to the third power. The value of 10 to the third power is 1,000. We can write this repeated multiplication expression as an exponential expression using a power of 10 with a smaller number after the 10 to show that 10 is being used as a factor 3 times. We read this as 10 to the third power. 10 multiplied 3 times can be written as 10 to the third power. These are both ways to write expressions that have a value of 1,000. This works with all numbers, not just powers of 10. For example, I can rewrite the repeated multiplication of the factor 2 by using the number 2 as a base. To show that 2 is being multiplied 4 times, I can write 2 to the fourth power. 2 is the base and 4 is the exponent. You will often be asked to evaluate an exponential expression. This means to find the value of the expression. I can evaluate an exponential expression by using repeated multiplication. If I have the expression 6 to the third power, I know to take the base 6 and multiply it 3 times. The value of 6 to the third power is 216. Can you identify the base and the exponent in this power? Were you able to correctly identify the different parts of the power? 3 is the base and 5 is the exponent. 3 is used as a factor 5 times. 3 times 3 times 3 times 3 times 3. You have probably heard of the word base before. Perhaps you start a video game mission at a military base. You may have held a microscope by placing one hand under the base. In the case of exponents, the base is the number we start with and repeatedly multiply. When you look at the exponent, the base is the number that is touching the ground, so to speak. Remember that we can write exponents using any number, not just whole numbers. You can have negative numbers, fractions, and decimals in exponential expressions. They all follow the same basic pattern of repeated multiplication. So why know this stuff? Using exponents is the fastest way to solve problems that involve repeated multiplication. This will make difficult math problems much easier to understand as you go on to take classes that teach about making money, the spread of germs, birth and deaths of a community, and more. If you ever plan on owning a home, then you will eventually have to work through some area and volume problems. The units used to represent area and volume are common examples of exponents. Area is measured in units squared. Volume is measured in units cubed. Go on to answer the reflection question on page 145. This question is counted as a classwork grade. Is 2 to the 7th power equal to 2 times 7? Explain.